Welcome back, Shareler area. This is Unit 2 Chemistry, and this is note video number 6. So we just finished taking the Chem I quiz. So we've talked about the states of matter and how it's the motions of the particles that dictate the states of matter and how thermal energy dictates the motion of the particles. So now we're going to start moving on and actually looking at atoms, and then we're going to move on beyond that and discuss the periodic table, where it came from, and how we can use it to put things together, use it as a tool. So it all starts with the atom. So our understanding of the atom has changed a lot over history, even with the first person who had the first idea, and that'll be what the next note video is about. But before we get into that, let's discuss what we believe the atom to be like now, or at least the easiest model for you guys to understand. So at the foundation, all matter in the entire universe is made of atoms. So anything you can think of, anything you can touch, is made of atoms. And these atoms themselves are made up of two regions. So we have an inner region in here, and this is called the nucleus. And then everything around the nucleus is called the electron cloud. So when we talk about atoms, we're going to talk about particles that exist in one of these two places. So either we're going to be talking about the nucleus and what exists in there and how it behaves, or we're going to talk about the electron cloud and what exists in there and how it behaves. So the nucleus is in the middle. So it's the very center of the atom, and it contains most of the mass. And by most of the mass, like 99.99999% of the mass of any atom is found in that very central spot, and a relatively tiny spot. The electron cloud, on the other hand, is everything around the nucleus, and it contains very little of the mass, and it's where we find the electrons. That's why it's called the electron cloud. To give you an idea as to how difference in size or what's actually happening inside of the atom. Remember, atoms are really tiny. Everything is made of them. One of those models in the modeling kit would be an atom. So if you want to think about holding that. So the ball part of it, if you had like the hydrogen atom, or if you had the sodium atom, the ball part of it is the nucleus. And then that arm that sticks out with the little metal ends on them, and they're magnetic on the modeling kits, those things are kind of representing the electron cloud. Although the size relativity is in the modeling kit is not right. But that's kind of how you want to think about the structure of the atom. So if we took an atom and blew it up to the size of PNC Park, so the entire stadium is the atom. So the outer parts of the stadium would be the outer edges of the electron cloud. And then we took a pencil, tore the eraser off of it, and stuck it down on the pitcher's mound. That would be a really good size comparison to the entire atom, like the whole size of the electron cloud, and then the size of the nucleus down there on the pitcher's rubber. Most of the mass is found in that tiny, tiny, tiny little thing down there. That's where we find all the protons and all the neutrons. And the rest of this space is occupied by electrons. And these are the tiniest bits of matter. They are almost non-existent. They are so small. And they also are the fastest pieces of matter. They get very, 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 very close to the speed of light, which is the maximum speed of light. Things that have mass can't actually go the speed of light. And then there's a whole discussion about light, and light has a tiny little bit of mass, and there's some interesting things that go on once you start talking about really small amounts of mass and really high levels of speed. So what are these particles that are found in the eraser and in the electron cloud? So in the nucleus, we have neutrons and we have protons. And these are the two things that give an atom its mass. So the neutron, found in the nucleus, it's got no charge, and that's going to be important. About these three things, you're going to need to know where they are and what charge that they have. Well, a neutron has no charge, and it's slightly larger than a proton, just a tiny little bit larger than a proton. The proton's also found in the nucleus, and it has a positive charge, P for positive, P for proton. It's a nice way to remember that. And it has a mass of what we call 1 AMU. And an AMU is an atomic mass unit. And essentially, when we started figuring out that there were things inside of atoms, and we were able to isolate one of those things, we were able to do it with a proton, so we base everything else on the size of the proton. So that means that a neutron is slightly bigger than a proton, and a proton is kind of what we base everything else against. Now, an electron is what's zooming around in the electron cloud out there. It's negative, so it's got the opposite charge of a proton. And it is 2,000 times smaller than a proton, so it's really, really, really tiny. So if you want to think, and this plays a role later when you start to learn about like radiation, if you want to think of a neutron as kind of being a proton and an electron combined, then the charges cancel each other out, and that makes it slightly larger than a proton because you're kind of adding this little tiny little bit of mass to a proton to make a neutron. That's one good way to think about it and kind of understand what's going on. When you really start to get into advanced theoretical super subatomic particle chemistry, that idea doesn't quite match up with what's happening at the super small mechanics, but it's a good way to think about it. So proton's positive, found in the nucleus. Everything else is based on its size. Neutron is kind of like a proton and electron put together. No charge, just kind of sits in there. And it has a very important function, but we'll talk about those later. And the electron is the super, super tiny piece of matter that zooms around in the electron cloud at nearly the speed of light and has a negative charge. And if you can remember the three parts of the atom and the two regions of the atom, that's super important to understanding what's going on later. So there's going to be 9 questions about that in our next booby trap. Have a great day.